Today's entry question is, what are the types of substations and tell the important components in a substation. Substation may be defined as equipment or assembly of equipments which changes one or more characteristics of the supply. Example, power factor, frequency, etc. And we know it very well. Power system is a combination of generation, transmission, distribution. Without substations, we can't transmit power or distribute power. And types of substation, there are 9 types of substation. But in general classification, on the primary substation, secondary substation, distributed substation, grid substation, all of them. Before seeing the types of the substation and its component, now we will see the structure of power supply system. This is a simple schematic diagram of power supply. In India, we are generating 11,000 volts or 11 kV. That 11,000 or 11 kV is step up to 220 kV for reducing the transmission loss. The 220 kV line is fed to the primary substation. There they are stepped down the voltage to 110 kV or 66 kV or 33 kV. This is called the primary substation. This is a main transmission line. Here the two voltages are available, 66, 33. Sometimes 110 also available. Here I consider only 66 and 33. So this is a secondary substation. In the secondary substation, here 66 bar 11. Here the 11 kV is available, here the 11 kV is available. One feeder goes to the distribution substation. This is distribution substation. Here also distribution substation. Here the 33 by 11, this is 66 by 11. In the distribution substation, 11 by 415. That is goes to the domestic consumer. Here the 11, that is 33 by 11, again we are 11 by 415 goes to the domestic and the commercial consumers. Substations are generally classified as indoor substation and outdoor substation. There are 9 types of substations. Number 1, switching substation. For switching operation of power lines without transforming voltage level to another level as per need is called a switching substation. Number 2, grid substation. Here the bulk power is transmitted from one point to another point in the grid is called as grid substation. This is a very important substation because any disturbance in the substation may cause a grid failure. Number 3, converting substation. This substation converting AC to DC or DC to AC and converting frequency from higher level to lower level. Number 4, frequency changing substation. This substation converting power frequency to higher frequency for industrial application. For example, high frequency heating, dielectric heating. We need high frequency. We go for a frequency changing substation. Number 5, power factor correction substation. These are used to correct or improve the power factor. They are also called as synchronous substation because synchronous machine is used to improve the power factor. The 6th is the mobile substation. These are needed for temporary requirements such as construction purposes. So it requires special design. According to the requirement, we have to design a substation. Number 7, cinematography substation. These are special substations and are required to meet the special requirements. It also requires some special design. Number 8, mining substation. These substations required for special purposes. They need a special design consideration because of the extra safety needed in the operation. Number 9, town substation. These are step down substations because we are stepping down the 33 or 11 kV for further distribution to the town. If any failure in the town substation, there is a total power failure in the town. Major equipments of a substation. There are 7 major equipments in a substation. Number 1, transformer, which is used to step up or step down the voltage. Number 2, bus bar is used to carry the heavy amount of current. Busbar is a thick copper or aluminum conductor that conducts electricity within a switchboard or a distribution board. There are two types of distribution board. One is a main distribution board, another is a sub-distribution board. The third is isolator switches used for isolating the power. Isolators are operated under no load condition. They are not equipped with arc quenching devices. Where in the case of switches, there are so many switches: ironclad switch, switch to fuse, fuse to switch, and air brake switch. Air brake switch is not equipped with the arc quenching device, but oil brake switch is equipped with the arc quenching device. Here oil is a medium used for quenching the arc. The next is circuit breaker. Circuit breaker is a protective device. In event of fault, it will protect the system. That's why we are using circuit breaker. Another is fuses and relays. We are using two types of fuses. One is a rewirable fuse, another is a high rupturing capacity fuses. Another is a relay. Relay is a device which sends the fault and gives a signal to the circuit breaker. There are so many relays. The seventh is a control boards. Here the bus bar, isolators, circuit breaker, relays are housed in the control boards. The control boards are placed in the control room. There the control boards, switched bank capacitors and metering unit, everything there in the control room. From there we can control the overall system.